Good morning, good morning, good morning. There we go. I like that a lot better. God, is everybody here already? Let me take roll and find out. All righty. Barry?
Here.
Raina?
Here.
Zach? Alexis? Alexis? Let's see. Caleb?
Here.
Sarah? Sarah? Gabe?
Here.
Lily?
Here.
Tucker?
Here.
Grayson?
Here.
Karina?
Here.
Gibbs?
Here.
Ella?
Here.
William?
Here.
Bailey?
Here.
Sophia?
Here.
Jaden?
Here.
Morgan?
Here.
Jordan?
Here.
Audrey?
Here.
Alrighty.
Mr. Kruger, there's some people in the waiting room.
Oh, they're in the waiting room? Waiting room, they're waiting. Alrighty, let's get to the waiting room.
That one came up on mine too.
They're in the waiting room. How come I'm not showing them? They're in the waiting room.
Let's see.
I don't have them in the waiting room. Are they saying they're in the waiting room?
Your eyes are so hard I can't see it.
Oh, now they're showing up. All right, Alexis. Anybody else in the waiting room?
Yeah. Yeah.
All righty. I am going to go over what I gave you that was due last night. I'm going to talk about a couple of problems, and then I'm going to finish up the notes, and then I have a pop quiz. And that's how it's going to be today. And when you're done with the pop quiz, if you choose to leave, you can. If you want to hang around and ask me questions, you can do that. All righty. So let's see if I can be successful and share my screen. There was a lot of good conversation last night. I was pretty pleased. I tried to do the best I could on my phone. And so here's the problem right here. A plane begins to take off at 2 p.m. on a 2,500 mile flight. The plane arrives at its destination at 7:30 p.m. Ignore the time zone changes. Explain why there must be at least 2 times on the flight when the speed of the plane was 400 miles per hour. Assume the flight is continuous and differentiable. And those are always 2 big ideas. And so what I'm going to do is I'm going to come up with an average rate. And to come up with an average rate, I need 2 points. And so even though it says 2 p.m., I'm going to say that's my starting time, and that is in hours. And let me just take care of this. Okay, this is in hours, and I went a distance of 0 miles. And so the y value is miles, the x value is hours, and that's something to remember. After from 2 to 7:30 is 5.5 hours. I went 2,500 miles. And so if I do the average rate, which is the slope of a secant line, which is our traditional slope formula, it's going to be 2,500 minus 0 over 5.5 minus 0. So if you had just given me 2,500 over 5.5, and I think it's 454 miles per hour. Is that correct, William? Something like that?
Yeah, just about.
Okay, so if we know the scenario, we're on the tarmac, we're not going any speed, and all of a sudden we take off, and we've had to go faster than 454. Would you agree with that, Jordan Smith?
Yes.
Why?
Because if that's just the average, there has to be points above and below to make it.
Right. There has to be speeds in which we're going faster than that, right? And some of those speeds were 0. Right? And we're averaging at 454. So by MVT, since it's stated it's already continuous and differentiable, I don't have to say that. By MVT, I know there must be a time in 0 to 5.5 where the plane's going 454 miles per hour, exceeding the 400, right? So you had to go by 400 on the way to 454, right? By IVT. And then since you land and you stop when you land, you had to decrease your speed to get to 0. So there has to be at least 2 times where you went by 400 miles per hour. And a couple of you I was pretty pleased. You could have just said that, but you said by IVT, because guess what? There's a value from 454 to 0, which is 400, and I had to go to that speed. So that's kind of what I was looking for. Is that kind of making sense? All right, we're going to look at this again. You'll see this kind of question right here on a quiz, and I will be looking for how you calculated this, and then by saying, if I don't say that it's continuous and differentiable, you don't have to say it. You just have to say by MVT, there must be a time in this interval where the plane was going 454, which is, and then explain, it doesn't go, then explain why you had to pass 400 twice. Bailey, did I do a good job explaining that?
Yeah.
Okay. All right. Here's another one that is quite common. In fact, I have not seen an AP question that doesn't have this, where all they give you is a table. And so, in fact, we had Hawaiian pizza just the other night, and it is my favorite with extra jalapenos. And I do occasionally stand by the oven and just watch it go up, but I made this up because I wasn't going to stand there for 30 minutes. And I don't think it takes 30 minutes to get there. And so an estimate, the key word is estimate, because there is no way, 18 even isn't a time in here. There isn't even a way to come up with the exact derivative. It's impossible. We don't have an algebraic function. We're just given some times and some temperatures. But we can use the mean value theorem. And what I do first is I take a look and say, all right, what is the smallest interval that 18 is in? Well, it's from 15 to 20. So I have 2 points, 15 comma 275 and 20 comma 325. Now, the 15 and the 20, notice I put them as the x coordinate because they're my input. And I actually wrote it like that. Over time, the degrees change. And these are minutes, and that's going to come into effect right here. And these are degrees Fahrenheit. All right, so now I'm going to start the mean value theorem that says, hey, I need to know the slope of a secant line. So it's going to be 325 minus 275. Again, this is what you would have to show for AP, and you get credit for that. In fact, this whole section would be 3 points. And I believe you get 50 divided by 5, which is 10, correct? This is the slope of the secant line. It's the average rate of change between 15 and 20, correct? By MVT, and now notice it also said considered continuous and differentiable, so I don't need to say it because the person who wrote this already knows it is. So I can say by MVT, there must be a time in this interval, and I guess down here, that's my explanation, time in this interval from 15 to 20, where f prime, and I'll say t, I guess, for time, equals 10. Now, I don't know if it's at 18. I just know it's somewhere between 15 and 20, but I'm just asked to estimate anyway. So it's my best guess. So I'm going to say, and this is how I write it, that the derivative of 18, the derivative with 18 in it, is approximately 10. Now I asked for the units. Well, again, this is where my y units are degrees degrees Fahrenheit per minute. So with somewhere in this interval, the temperature changed at a rate, at an instant, of 10 degrees Fahrenheit per minute. And that's my best estimate. And you see that all the time. Now, where are the 3 points you would get on the AP? You would get it for this, you would get it for this, and you would get it for the units. 3 out of 9 on that question. But you're allowed to do that because you're computing the slope of a secant line between these 2 points. Somewhere within in this interval, in this graph, there's a tangent line that has that slope. Excuse me, I guess these two, I was picking the wrong two. And 18 is for that 18, that's the best estimate I have. But knowing that I don't know what it is exactly, that's why they use the word estimate. Okay, is that making sense to everybody? And they're very two different problems that deal with the mean value theorem. Jaden, am I going too fast or am I going at a okay pace?
You're going at an okay pace.
Okay, and I'm gonna, and I'll put these again on the lecture portion on Schoology. When I'm at home, it takes so long to download. I gotta call Spectrum and find out what the deal is. It's terrible. All righty, so we're on these notes. And I believe we are on number 2. Am I right?
Yeah.
Yep.
Okay. Yes?
Yep.
Okay. So again, this is going to be a question you're going to see on the quiz on Tuesday. And I'll just read it. And 2 stationary patrol cars equipped with radar are 4 miles apart on Highway 52 south of Cannon Falls. As I pass the first patrol car, my speed is clocked at 60 miles per hour. Well underneath the actual speed limit, which is 65 miles per hour. 3 minutes later, I pass the second patrol car and my speed is even slower, 57 miles per hour. I'm a well law-abiding citizen, Jordan. Okay. Prove using the mean value theorem that I actually speeded. I exceeded 65 miles per hour at the time, sometime during the 3 minutes. Now notice, notice that it's very similar to the question like the airplane. Would you agree? So I'm going to set up my ordered pairs. Mean value theorem means I need to come up with the slope of a secant line. in here doesn't say anything about continuous and differentiable, so I'm going to put that in my statement. Okay, because it's not like all of a sudden I disappeared on Highway 52 and reappeared. It's time is continuous between those two spots. So the big thing you got to be careful of is when you start, when I got first clocked, my time is 0. Now, you got to be careful on this spot. Audrey, what unit am I going to use for time?
Would you use minutes?
I can't because I want to see that I exceeded miles per hour.
Oh, okay.
Does that make sense?
Yeah.
Okay, so we're going to have to choose hours. And then this value is going to be miles because the rate I want to look at is miles per hour. So there's a time period that I went 4 miles. Now, Audrey, 3 minutes is how much of an hour?
Would it be 0.03 minutes? Wait, I can brain. It'd just be 0.3, right?
Yeah, well, it's 3/20, and isn't it 3 out of 60?
Yeah.
Yeah, so I get 1/20. Is that okay? Which I think is 0.05. If you take 3 divided by 60. Audrey, okay?
Sorry, yeah, I forgot.
Okay. No, it's all right. It's all right. This is all righty. So, Caleb, I am now going to do my slope of my secant line, or my average rate. 4 minus 0. I'm subtracting the y's. 1/20 minus 0. So what I'm doing here is this f of b minus f of a over b minus a. You don't have to show me that, but that's what I'm doing. So I get, Caleb, 4 divided by 1/20. What is that?
Is that 80?
That is 80. That's exactly correct. 80 what?
Miles per hour.
Miles per hour, which is my what rate?
Average.
Average rate. And like Jordan said, I must have even been going faster than 80 miles per hour in those 3 minutes. I was driving like a crazy man. I saw the policeman, slowed down quickly, sped up, saw another policeman, slowed down. So I am going to say since Kruger's driving is continuous and differentiable. By MVT, there must be a time in 0 to 1/20 where he, I'll write it down here, was driving 80 miles per hour, exceeding the speed limit. So somewhere in those 3 minutes, boom, things had to be crazy. Rena, okay?
Mr. Kruger,
Yes.
How did you get 4 miles?
I'm told 4 miles in the problem. It says the 2 patrol cars
Oh,
equipped
okay.
with radar are 4 miles apart. I passed the first one, and 3 minutes later, I passed the second one. That's a great question.
Okay.
Alrighty. You know a couple of things. Can I move on, Karina?
Yep.
Okay. So I know a couple of things here, but right here where it says it's always differential, if it's differentiable, you are guaranteed, that is, it is continuous. You know that for a fact. So this is a polynomial. If it's a polynomial, you know it's differentiable, you know it's continuous. Right here, this example is a rational expression. It is differentiable over its domain. However, not in the domain is this, 3x squared minus 2 equals 0, which is x squared equals 2/3. So plus or minus the square root of 2/3 is not part of the domain. And so you have problems if that's in the interval. This is okay too. Obviously, like if you have a square root, you can't have negative numbers in there. So you have to watch out for those. But everywhere else in the domain, it's differentiable and continuous. Likewise, our trig and sines are always, for everything, since it's nice and wavy, differentiable and smooth, differentiable over the entire real number system. Okay, so that's just a little bit of review. So we're going to look at a special situation of the mean value theorem. It's called Rolle's theorem. And the idea is that if you have a function that's continuous and differentiable, continuous on a closed interval and differentiable on an open interval, these 1s and 2s I'll explain later. And then there's a third thing, that these y values are the same when you put a in and you put b in. A real common one that I use on example is f of x equals x squared. If I put -2 in there, I get 4. And if I put 2 in there, I get 4. So this would be an example where a and b are equal. I would have a graph that looks like this. And if I connected those 2 endpoints by that graph, I would get a horizontal line. Which means its slope is equal to 0. Well, since that's the slope of a secant line, it's 0. That means there's somewhere in this interval, there has to be a horizontal tangent line, which it is. So it guarantees, since you're at 2 different y values, in other words, you started with a certain a value at a y position, and as you move to the other b value, you're back at that same position. There had to be a turning around point somewhere with that in that interval. You're guaranteed that when you have Rolle's theorem. You have at least one turning around point. So let's take a look. And so that's what that's saying when f prime of c equals 0. So c is going to be the x value of where that turning around point is. So here's an example. And so the 1 means, is it differentiable? That's the first thing I take a look at. So Ella, is this function differentiable?
Yes.
I agree. Why?
Because you can take the derivative of it.
Yes, you can. But generally speaking, it belongs to a group of functions. What kind of group of functions?
It's a polynomial.
It's a polynomial. Correct. And you can take the derivative of any polynomial. You just use the power rule, correct? So Ella,
Yeah.
because there's a check mark here, you are guaranteed to get a check mark here, which means continuous. So I always check for differentiability first. Okay. And we're going to do one where it's not differentiable here in a bit. So once I've done that, Grayson, I got to put in A. So A is 0. So if I put 0 into F, what do I get?
0.
0. And then I'm going to put B. And if I put B in to F, what do I get when I put 2 in?
0.
0. So F of A equals F of B, correct?
Yep.
So that checks. So that means there's a turnaround point. So I'm going to take the derivative and Raina, why don't you take the derivative of this for me?
2x minus 2.
Right, so I'm going to write it as 2c minus 2 to figure out what that c is, and I'm going to make it equal to 0. And what is my c then?
1.
1. So over here, this is 2x minus 2. C is 1. So right here, I got 0, 0. Right here, I got 2, comma 0. Right here is x equals 1. So how do I figure out what my turnaround point is, Raina?
You plug 1 into the original equation.
Yeah, so I figure out f of 1. And what do I get?
-1.
-1. So there's a turning point right here of 1, -1, like this. Bingo. All right, very good. All right, what does this mean? 1, comma -1 is an absolute minimum. Okay. All right, so here I goofed up. Oh, I got too many of those. I got a piecewise curve. And I'm going to try to show you the piecewise curve. That's my goal. I did not want this. And I'm going to try to share with you my other screen. I believe this is it. Will, do you see that?
Yep.
Okay, that's Desmos. Can you see the red lines okay?
Yep.
All right. So this is the piecewise curve. And if you take a look, this is how you put a piecewise in case you ever want to create a piecewise graph. You can check it using Desmos. And I don't even, I just hit graphing calculator and it does this. So you need this bracket symbol. You need to say where you want it less than or equal to. And so I said less than 0 because I'm told that. And then you follow by a colon. And then you follow by what the function is. So in this case, it was a -2x. And then you follow by a comma. And then you do your next part. So it's greater than or equal to 0. And then a colon, and then x squared. So all I did to figure that out is I Googled piecewise graph in Desmos. And that's how I figured that out. So if I look at that, Gibbs, what does this spot right here look like?
Is that possibly a sharp point, Mr. Kruger?
Yeah, possibly a sharp point. That's exactly correct. Okay, and I had Desmos figure out what the derivative is, and you can do that. I just wrote g of x equals f prime of x, and I turned it off here. And if I turn it on, you can see it's right here. Do you see it in blue?
Yep.
Okay, and Grayson, why is it at a -2 all the way along here?
I'm not sure.
Okay, we'll talk about that in a bit. Okay, and this right here is a line, and it looks like it's the equation. Grayson, would you say it's the equation 2x?
Yeah.
Okay, and there's a big gap here, isn't there? Right?
Yeah, there's a jump.
Yeah, and so that gap means it's not differentiable at 0, but because it's continuous here at 0, that's got to be a sharp point. Okay, so that's what it looks like graphically. I'm going to show you how it looks calculus wise. So I'm going to stop sharing here and I'm going to go back to my ladybug. And so what I'm going to do here, this is how you take the derivative of a piecewise. And I do it line by line. So Gabe, what's the derivative of a negative 2x?
-2.
Negative 2. And that's for all x's less than 0. So this line stays the same. All you did was take the derivative of that. Grayson, does that make sense why there was a horizontal line at a negative 2?
Yeah.
Okay. And then back to Gabe, what's the derivative of x squared?
2x.
2x. And that's x greater than or equal to 0. And Grayson, does that make sense where 2x came from?
Yep.
So as I approach 0 from the left, my y values or my derivative will always be a negative 2. As I approach 0 from the right, it goes to 0. That's why we saw that jump. So if we go through our conditions, 1, 2, 3, the question, is it differentiable? The answer would be no, it's not differentiable. However, if I go back to my graph, and I get rid of the derivative so you don't get confused, this red line is continuous all the way through. It's continuous. So if I would go back to our notes, this is true. And if I put a negative 2 into here, well, negative 2 is less than 0, and negative 2 times negative 2 is 4. So f of negative 2 is equal to 4. And 2 is greater than 0, so I'm going to square it. So f of 2 equals 4. So f of negative 2 equals f of 2. So that would have checked, but you got to have all three of these checked. So the most important part here is deciding whether it's differentiable or not. Right away, when I got a no on differentiable, I could have said no, we cannot apply the MVT, mean value theorem. And that's why the reason I checked the other two was to show you these other two could be true. You could look at this and say, yeah, it is. You could have looked at this and said, yeah, it is. But if you didn't look to see if it was differentiable, you needed it to be wrong. So what I do, that's the first thing I do to see if it's differentiable. And on a piecewise, the way I do that, and that's where it seems to come up the most, especially on multiple choice questions on the AP test, is they give you a piecewise, they ask you if it's differentiable at a particular point or a particular x value. And what I do is I go through and I take the derivative and then I examine it from there. Morgan, any questions on that?
No.
Do you think I need to do another example or you think it's okie doke?
I think it's okay.
Okay. What I would like to do is give you guys a pop quiz. And the way you're going to get to that pop quiz is you're going to go to